Hello class, it's Mr. Duffield here with a continuation of Unit 8, which was about quadrilaterals, but we're going to look a little bit beyond quadrilaterals and look at polygons. Prefix poly means many, gon means sided figure, so we're looking at many-sided figures. So whether it's a triangle, which has 3 sides, a quadrilateral, which has 4 sides, a pentagon that has 5, hexagon that has 6, septagon, which has 7, octagon has 8, and so forth. So we're going to look at some different shapes here. These are the notes for finding the perimeter and area of polygons. Perimeter is the distance around the specific shape. Essentially what you're looking at is adding up all the sides, but there are some formulas that you need to know which make things easier rather than having to add up all the sides, especially when you don't have all the sides information. Also, we'll look at finding the area of polygons. Area is the amount of space that something takes up. So let's take a look at some examples and follow along and fill in your note sheet. First shape we'll look at is a square. Perimeter of a square. Perimeter is the distance all the way around, so the perimeter, which we'll call P, equals 4 times S. S stands for side, as you can see, side, and we know that in a square, all 4 sides are the same length. To find the area equals whatever the side length is squared. So remember, square means to multiply it by itself. So for example, if the side is 4 units long, we do 4 squared, so the area of this square would be 16, for example. Let's move along to a triangle. Triangle, as you can see, we have triangle A, B, and C are the different sides. We'll call this angle A, this angle B, and this angle C, just for purposes later. But the little letters have to do with the length of the sides, and that's what we're going to focus on for the perimeter. So the perimeter, P, equals A plus B plus C, whatever the 3 sides are added together. No simple formula for that. To find the area of the triangle, the area equals 1/2 B, which stands for base, times H, which is height. Well, what is the base and what is the height? Well, let's look at our triangle. The height is the distance from a vertex straight down and is perpendicular to the opposite side. That opposite side will become the base. So there you can see whatever this distance is right here becomes the height. The base will become the distance of C, or the length of C. Now, if we're using the angles, which is not very common, but if we were, we could say that the area equals 1/2 A, B, so the length of side A, the length of side B, times the sine of C. We're not going to really use that all that much, but it's just helpful to know that in case it does come up. We're really going to focus on this one here, the perimeter, and this area equation. So let's continue on and look at perimeter of rectangles or parallelograms. So here you can see this is a rectangle. This is a parallelogram. Perimeter. On both of these you can see base is the bottom or the top of the figures. And the height is the vertical distance from one base to the other base. In the parallelogram, you can see that the height is kind of a dashed line. It's not that side that is at an angle, it's that vertical line. So the perimeter is just 2 times the base plus 2 times the height. And that's because we have 2 bases, the top and the bottom, and we also have 2 heights, which are the 2 sides. So that would give us the perimeter for rectangle and parallelograms. The area is just the base times the height. That's pretty simple. Let's move on to a polygon with greater than 4 sides. So in this particular shape, we can see it's actually a pentagon to be specific. The perimeter, again, is just where you add up all the sides. So this would be A plus B plus C plus D plus E. So we have 5 sides, so we're adding up all 5 sides to find the perimeter. To find the area of a regular polygon. So what's important to know is this is for any polygon. So anything that has greater than 4 sides, like it says in the directions, anything that has greater than 4 sides. So it could be 5-sided, 6-sided, 7-sided, whatever the case, it doesn't matter, it's the same formula for the area. The area equals one of the side lengths, we'll say A, times P, we'll talk about P in a second, divided by 2. What does that P stand for? P stands for apothem. What that is the distance from the center of the figure vertically down where it makes a right angle. That's your P. So sometimes you may have to find that distance. Hopefully a lot of times they're going to give that to you. But whatever that distance is, times one length of one of the sides divided by 2 will give you the area. Let's look at some very specific shapes. We'll look at an equilateral triangle. We know an equilateral triangle has all 3 sides the same. So S is the length of one side, so this would be S, this would be S as well. The area will be square root of 3 divided by 4 multiplied by the side length squared. For a trapezoid, so trapezoid is a different type of quadrilateral. It's not a square, rectangle or a square or parallelogram. So a trapezoid, as you can see, we have base 1 here, base 2, and we have a height. So the area equals that height multiplied times the sum of the 2 bases, all divided by 2. For a kite, as you can see, AC is one diagonal, BD is another diagonal in this kite. So the area of the kite is diagonal 1 times diagonal 2 divided by 2. Notice this one has nothing to do with the sides of the shape. Just has to do with the diagonals. Now, one of the things you may have noticed is I haven't really described why these are the formulas. I don't think that's necessarily important for us to know, but as long as you know the formulas and can plug the proper values into them and then solve, we should be good for our class lessons, homework, assignments, and also the SWL and so forth. So just know these formulas. A few more to look at. Let's look at a rhombus. Rhombus, if you remember, has 4 congruent sides. But we want to look specifically at the diagonals. We have diagonal AC and diagonal BD, and that's what's important for the area. The area of a rhombus is diagonal 1 times diagonal 2 divided by 2. So it's the same as a kite, essentially. And the last one, for a circle, we're going to look at circles more in the next unit, but for a circle, the circumference, which stands C, is equal to 2 pi r. R, as you can see, is the distance from the center of the circle out to the actual circle. That's called the radius. So r is short for radius. Pi, as you know, is a universal constant. We always just use 3.14. 3.14, it goes on forever. It's a never-ending number, but we just shorten it to just 3.14 for our terms. We like to keep that in just terms of pi, though. So that's why your answer will be written as pi rather than using the decimal, unless it specifies otherwise. But the circumference is 2 times pi times the radius. For the area equals pi times the radius squared, or pi r squared. So as you can see with these formulas, you need very specific information in order to figure out perimeters and area. Sometimes you'll be given that information, sometimes you may have to find it using stuff that we've learned in previous units. So just keep that in mind, and that completes this lesson. Hopefully you understand it and are able to apply these formulas to do the assignment. If you have questions, come and see me. Good luck, everybody.